Hi, I am Anubhav, a final year electronics and instrumentation engineering student at NIT Silchar. What you are about to see is GeoDrishti, a multi-agent AI system I built for agents for good track. To solve a real problem, Majuli, the world's largest river island, is disappearing. Majuli sits in the Brahmaputra River in Assam, and over the last few decades, it's lost a huge portion of its landmass to riverine erosion. Thousands of people have already had to leave. Satellite data has been tracking this for years, but there's never been a system that turns that raw data into something a disaster response team can actually act on. That's what GeoDrishti does. Now this is the GitHub repository. It includes all the file, the details about the project, the system architecture and workflow, which includes three agent pipeline, which we will come to it in a minute, and the data and methodology part, the tech stack, and the setup and installation. Following this setup and installation guide, you can set this up locally in your system. Now let's go to the dashboard. So this is the GeoDrishti. Uh, so this is the dashboard. On the map, you can see the historical erosion zones, flood inundations, areas, and vegetation health data for the Majuli Island, layered directly onto the satellite imagery. By using this tab, you can select whichever data you want. On the left, we have a chat interface. Uh, this is where the real intelligence lives. It has three AI agents working together in sequence, and on the right you have got pipeline and trend graphs. And if I scroll down, the mitigation plan as well, but that card is currently missing because we haven't asked for a query yet. Now let's talk about the three agent pipeline. For that we need to ask this agent something. So I'm going to ask about the 2020, which is the worst erosion year in our dataset. Now what happens? Now agent A is fired up. The GIS operator. This takes this plain English question and converts it into structured data. Data range, coordinates, bounding box. It's not hard coded to Majuli either. It can resolve almost any place on earth, which you will see shortly. So this is the pipeline and agent has currently fired. Now let's see if the response have come. Uh, so the response shows the details about uh, the 2020 year which we asked. What happened after agent A is agent B, the environmental analyst, produced this report. Notice it clearly separates the historical erosion figure for 2020 from a live satellite reading from today's date. Early on, these got blurred together in a way that was actually misleading. The system would cite today's satellite image as evidence for the 3-year-old number. I had to explicitly fix that because in a tool meant for real decision, that confusion matters. Now let's see the mitigation action plan card which I talked about previously. So the mitigation plan here is what comes after agent B, which is the agency. The resource planner has calculated a real mitigation plan, geobags, tons of bamboo, and an estimated budget. It's answering not just is this bad, but what do I need and what will it cost. These historical numbers aren't placeholder data. They are derived from the real Sentinel-2 satellite imagery through Google Earth Engine, specifically dry season composites from January through March 2018 to 2025, using only the dry season filters out monsoon flooding, so I get a real erosion signal instead of a seasonal noise. Now let's ask another question to this agent. Now the same loop again fires up agent A, then agent B, and then agent C. Everything will be live in a minute. So the response have come. So the system report shows zero net land loss, and because this was actually an accretion year, sandbars reformed, the island gained land back. Uh, that's that's what happens on real braided rivers like Brahmaputra. And I wanted the system to be honest about it, not declare every year a crisis. Uh, we also have another feature on this, which is the emergency dispatcher. I can just ask it to email this to DDMA, which means the District Disaster Management Authority. So once I have a report, the next question is who needs to know? I built this dispatcher for exactly this. Say it in plain English and it pulls out the most recent analysis and sends it. This send is simulated for demo reliability, but it's built from the same tool calling structure a real SMTP or SendGrid integration would use. Swapping it means in changing one function, not redesigning anything. So when I send this, uh, it gives it gives a toast disaster district management, uh, and it gives me a notification here. Emergency report successfully dispatched to District Disaster Management Authority. Now let's ask another question, which is one of the another feature that you're going to about to see here. Erosion of Tokyo. We just ask it this question. So what I was talking about is GeoDrishti isn't hard coded to Majuli Island. Uh, Ask it about any place like Tokyo, and the same pipeline runs. But in its upfront that historical data only exists for Majuli, relying purely on live telemetry here. It doesn't invent a history, or it doesn't have. A lot of AI demos will happily hallucinate plausible answer, but this one says I don't know when it genuinely doesn't. It gives me a report about the erosion in Tokyo, and it also brings up this data. Notice these data are different from those of Majuli because of the reason I explained just a time ago. Now let's test more edge cases. So a lot of my development went into these edge cases mostly. Early on, severity was entirely up to the AI's judgment per response. The same erosion data could come back as medium one time and high another time, just from how I phrase the question. I move the severity to a fixed deterministic threshold in code so that the same data always produce the same result. I also found that multi-year queries had a bug where the report only described the most recent year, while the mitigation plan next to it was calculated across the whole range. So you'd see no erosion sitting right next to a plan budgeting for hundreds of thousands of geobags. I rebuilt that logic to account for every year properly. I also fixed off-topic queries defaulting to fabricated Majuli analysis instead of asking for clarification, and a session bug where one query's result could leak into a completely unrelated later query. Building something trustworthy enough for real disaster data meant actually hunting for these failures and not just getting a demo to work once. Uh, so under the hood, let's we used a lot of the tech stack. Let's talk about the tech stack now. So we used React, White, and Leaflet on the front end, and Django and SQLite on the back end. The Google's ADK development kit, agent development kit, orchestrating the three agents, agent A, agent B, agent C, fast MCP for tool calls as the language model, and Gemini as the language model. The Google Earth engine for the satellite data. Now, let's talk about the future plans. A few direction I want to take this next is the first, the geographic expansion. The same Earth engine pipeline could be pointed to other flood-prone area of northeast India like Kaziranga, wider Brahmaputra Valley, or Barak Valley without changing the agent logic. Second, making the dispatcher real, wiring in an actual SMTP or SendGrid integration so that it can genuinely notify disaster management contacts. And long-term, a proactive monitoring layer so the system can watch the data on its own and raise an alert the moment erosion crosses a dangerous threshold without anyone needing to ask first. I built this for Majuli because it's the clearest, most urgent case I know of personally, but the goal was to prepare to generalize it always. With this, I end my presentation here. Uh, Thanks for watching. The full code and the code setup are available in this link, which you can see from here. So this is the link, and you can set this up. Uh, Thank you so much. Bye bye.